Good morning, everyone. Kayla, Hazel, Jose, okay, Jiawen, Ali. Okay, let me say hi to each one. Jiawen.
3.6 Derivatives of log functions. If y equal to ln of x, what will be the derivative of ln of x with respect to x? In other words, what will be y prime? The ln function is the natural log function with base e. It is the inverse function of the exponential function with base e. We can rewrite this equation in exponential form, and we can write that as x equal to e to the y exponent. For example, if 2 to the third equal to 8, this is equivalent to 3 is equal to base 2 log of 8. You see here, 8 is equal to 2 raised to the third exponent. Similar here, x here is base e raised to the y exponent. We know how to find derivative of exponential function, so we can use implicit differentiation to find y prime. First, we're going to differentiate both sides with respect to x. This function e to the y looks simple. However, it is a composite of two functions. The outer function is e to the y, and the inner function is the y. What is the derivative e to the y with respect to x?
e to the y.
Yeah, you got e to the y. By the chain rule, we have the times the derivative of this inner function. So what do I need to multiply here?
Y prime.
Y prime. So we have this y prime. Now on the other side, the derivative x with respect to x is 1. Now we just solve for y prime. Y prime will be 1 over e to the y. Remember, we want to go back to x. So notice that e to the y over here is equal to x. So that is 1 over x. Now we can use it as a formula. The derivative of ln of x is 1 over x. Okay, you guys got it? See, implicit differentiation is very useful, right? It helps you to find the derivative. Now, this is an important formula you want to remember. Sometimes you can use flashcard and put down those important formulas. Try to remember them. So when you do homework or anything, then it come in handy if you know those. Okay, now what happens if the log function is not of base e?
Say this base a here is any positive constant, not just e. So we are trying to find the derivative of this log function.
To do that, we can try to relate to the ln function because we know how to take the derivative of ln function right here, right? So we already got the formula. So we want to somehow relate this with the lateral log function. So we use the change of base formula. So what does change of base formula say? This is equal to ln of x divided by what?
I guess a.
Ln of a, right? So ln of a.
We are trying to find y prime, which means we're trying to find the derivative this with respect to x.
So we write this one here as 1 over ln of a times ln of x. See this 1 over ln of a here? It's just a constant, right? A is a constant. So 1 over ln of a is a constant. So it's a constant multiple. So we'll bring that in front of this derivative. So bring it out. And then differentiate ln of x. What's the derivative of ln of x? We just went over.
Yeah, it's 1 over x.
1 over, yeah, so that's 1 over x. So y prime will be 1 over x times ln of a in the denominator. Now, that's another formula that you want to remember. Okay, now let's put them together. See if you guys remember. E to the x, what's the derivative?
E to the x.
Got it. Good. Okay, a to the x.
bless.
Thank you. All right. So remember, this is an exponential function. Instead of base e, it is base a. E is also constant, right? So e to the x to the e to x. A to the x is similar. It will be a to the x itself. However, when the base is not e, then you have to times ln of
Oh, yes.
times
Mm-hmm.
ln of a.
Right.
So when the base is e, you times ln of e. Ln of e is just 1, so you get the same thing over here, right? Same expression.
Mm-hmm.
So you have this ln of a over here times this a to the x. Okay? Ln of x, the duality over here is 1 over x. Base a log of x, the duality here is what?
1 over.
X times ln of a, right? Okay. Now notice that you have this ln of a here. Okay, so if a to the x, you times it over here. If it's base a log of x, you times ln of a with x down here in the denominator. So there's 4 formula here for you to remember. Okay, now let's get to the next one. Y equal this. We try to find y prime. Now notice that this is the outer function, that's the inner function, right? So the outer function is ln of u. So we're going to differentiate this outer function with respect to u, which is what?
1 over u.
1 over u. The inner function is x squared plus 1. Differentiate that with respect to x. What do you get?
It's 2x.
2x. So the chain rule says that you're going to multiply this with this. So you're going to have 1 over x squared plus 1 times 2x.
Mm.
The u over here, it is x squared plus 1. So we at the end, we return back to x. So it's 1 over x squared plus 1. And then times 2x here. And then you can rewrite it this way. Okay, simplify it. Okay, the second one over here. So this is the outer, that's the inner. Okay, this time I'm not going to break it down like this. Okay, let's go ahead and do it. Okay, so differentiate the outer function ln of, think about this as u. Okay, differentiate this ln of u with respect to u. What do you get?
1 over sine x.
Yes, you get 1 over sine x over here. And then times the duality of this inner function. What's the duality of this inner function over here?
Cosine x.
Cosine x. See, you guys got it. Good job. Okay. Cosine x over sine x, it is cotangent x. So the result here is cotangent of x. Good?
Good.
All right. Okay, next one. Square root of ln of x. The outer function here, it is the square root function, square root of u. Okay, differentiate square root of u with respect to u. Okay, now notice that I had to do this one more time over here. You first rewrite that as u to the 1/2 power, and then you use a power rule to differentiate. So bring this 1/2 to the front, and then subtract this exponent here by 1, and then rewrite that as 1 over 2 square root of u over here. Next time, you try to remember this like a formula, okay? So the derivative square root of u with respect to u is 1 over 2 square root of u. Remember that, okay? The inner function here, it is ln of x. Differentiate this with respect to x, what do you get?
1 over x.
1 over x. So therefore, the duality of the function with respect to x, it is the product of these two. So that's the result over here. Question number 4. Now, this function over here, notice that you don't put down any number over here under the log here. That indicates the base over here is 10. It's a common log. Because so common, people get lazy and they don't put the 10 there. So the outer function is, what's the outer function? Log of u. Think about this whole expression inside is a single variable u. Differentiate that with respect to u, what do you get?
1 over u.
1 over u times ln of 10. You have to multiply this ln of a with this variable, right? And a over here is the base for this log, which is 10. So times ln of 10 over here. The inner function over here, it is 2 plus sine of x. So what's the duality of this inner function with respect to x? Yeah, so cosine x. So the chain rule says that it is going to be this times this. So we copy that one over here times this. Okay, the product of these two. You guys good? Number 5, differentiate this. So the outer function is the Ln function. So by the chain rule, you have 1 over this whole inner function right here, and then times the derivative of this inner function. So you first use a chain rule. So first it is a composite. So you use the chain rule here first. Now for this part here, what kind of rule do you need to use in order to differentiate?
The quotient rule.
Yeah, so we have to use the quotient rule here. Now first this 1 over this is a reciprocal this. So you're going to flip this, right? So flip this, we got that. And then this part here, we use the quotient rule to differentiate. So the quotient rule says that you're going to square the denominator. Up here, you differentiate the function on top. The derivative of x plus 1, it is 1. And then times the function down here. So times square root of x minus 2. And then minus or plus over here?
Minus.
Minus. Okay, so minus. Now this time you copy this function on top. So x plus 1 times the derivative of this function down here. What's the derivative of square root of x minus 2?
1/2 x to the negative half power.
Okay, look over here. Okay, the derivative square root of x minus 2. Think about this inner part here like a u. So you have 1 over 2 times square root of this whole thing right here inside. And then times the derivative of this inner function. The derivative of this inner function, derivative of x here is just 1. Derivative of constant is 0. So the derivative of the inner function here is 1. So times 1. So the derivative of square root of 1, the derivative of square root of x minus 2, it is 1 over 2 square root of x minus 2. So this explains that. You guys got it?
Yep.
Okay, good. So that's why it's important to kind of remember this like a formula, because if we use it over and over. Now, when you get to this part over here, let's simplify this part right here. So I just rewrite this into this. Now, after that, we're going to distribute this. I'm going to distribute this one over here. Multiply that with everything in the numerator. Okay, so that times this give you x minus 2. This times this square root and this square root here will cancel, giving you x plus 1 over 2 over here. You see it? Now, down here we have x plus 1 times x minus 2. Now, this is a complex rational expression. So we want to somehow get rid of this 2 right here. So what do? We multiply up and down here by the LCD. Okay, what's the LCD here?
2.
2. So we multiply by 2, right? Okay, up and down. And then you do the algebra. So that will turn out to be this. So that's one way to do it. Isn't that looks very complicated, right?
So
That,
complicated.
it looks complicated because the quotient rule over here. Okay, the quotient rule here and the algebra. Now I'm going to give you another way to do this problem. So another way to do this problem is make use of those property of log. Log of the quotient, it becomes the difference of these two. And then when you have this exponent here, you can bring this exponent in front of the Ln. So the first thing we do over here, you're given this function, which is Ln of this quotient. Then we can rewrite this as Ln of this numerator, subtract Ln of the denominator because of this property right here. So Ln of this numerator, subtract Ln of the denominator. Now that way later on you don't need to use the quotient rule. Now it becomes the difference. Now this part here you can further simplify. This is a square root. Square root over here is the same as to the 1/2 power. So this 1/2 exponent over here, you can bring it in front of this Ln. So you have this 1/2 right here. Now, once you simplify this y into this form, you can go ahead and differentiate. Okay, so we find y prime. So y prime is equal to, what's the derivative of this? 1 over, remember the derivative of ln of u with respect to u is 1 over u. So this is 1 over what?
X plus 1.
1 over x plus 1, yes. Times the derivative of the inner function, but the derivative inner function is 1, so that's it, right? Okay, minus, now you have this 1 half. What's the derivative ln of x minus 2?
1 over x minus 2.
1 over x minus 2, okay? See how easy it is to differentiate? You can just leave the answer like this, okay? That will be correct. So isn't that so much easier? If you combine them using the least common denominator, you will get the same answer as the way that you use the first method. But looks like this method is a little bit easier, right? Isn't it?
Yes, much easier.
Right. I'm going to make a weak mark over here. So to differentiate function of this type, ln of a quotient, like the one we have done, or ln of a product, or ln of a function raised to the some exponent over here, it will be easier to simplify first using this three property of ln. That way, when you differentiate, it's going to be easier because that way you don't have to use the quotient rule or product rule or chain rule right here. Okay, so this is one weak mark. So when you do homework, try to think about this. So when possible, if it's one of these three forms, you try to think about simplify this function here first, and then later on differentiate it with respect to x. Now over here, we know the derivative ln of x is 1 over x. What about ln of absolute value of x? What will be the derivative? Now this is the graph for ln of x right here. What about ln of absolute value of x? This is a graph for ln of absolute value of x. So x over here could be negative. So the domain for this function over here is all real number except
0.
So this part will be the same as this part, but when x is negative, it will be a symmetric image of this side about this y-axis. So this is the graph for ln of absolute value of x. Now first, we want to rewrite this function. Think about two cases, okay? So if x is greater than 0, will be equal to ln of x itself. What happens when x is negative? What should I put over here? When x is negative, absolute value of x equal to what?
Is the opposite of
Opposite of x. So this will be ln of opposite of x. Now notice that opposite of a negative, it is positive. So this is actually positive. Now we're going to differentiate this with respect to x. So differentiate this with respect to x, it is going to be 1 over x. What about if you differentiate this with respect to x? What do you get?
Negative 1 over x.
Okay, so you get 1 over negative x. That's the derivative of the outer, right? But you have the time derivative of the inner. What's the derivative of this inner function? Derivative of negative x with respect to x, it is negative 1, right?
Yep.
So you have the times negative 1. So the derivative of this outer, okay, is 1 over whatever inside. So it's 1 over negative x. And then times the derivative of the inner, which is negative 1. Now notice this negative times negative is positive. So the result over here is 1 over x. So in both cases, we got 1 over x. Now we have a formula. So the derivative of ln of absolute value of x here is again 1 over x. Derivative ln of x is 1 over x. Both of them, the derivative will be 1 over x. So what's the difference between these two? Can you guys tell me what's the difference?
Their domains.
The domain, yes. So the difference here is the domain. This one over here has a bigger domain. See, will be all real number except 0. This one over here, the domain will be only positive number. So this is actually has bigger domain. This one, the domain will have the same domain as 1 over x. The domain for this function is all real number except 0. domain for that is also all real number except 0. Okay? You guys good? Yeah, I'm going to stop over here. For log differentiation, I'm going to make a video. Okay. All right. Thank you for coming, and I'll see you guys on Wednesday. Okay?